So I built a shake table as instructed in a video that's in our PowerPoint. And so our our Jenga is to represent bricks because it doesn't move very well. It's not a very good shock absorber. Our clay is concrete. It's very good with movement. It's very it's not going to move much, even though it looks kind of sad. If I had used like steel pieces like they do with concrete, it would be a lot more durable than it is. Or even just using anything for support would have been better. And then finally is my Lego house. I think my Lego house is closest to like wood or something where there's a little more give because it's plastic, and plastic is a pretty good shock absorber. So let's see if my hypothesis is correct. So I'm going to shake my table to see what survives. As predicted, the Jenga table fell really easily because the wood isn't made to move, at least in this instance. Plastic is a better shock absorber than like would be in this scenario, but we don't really have anything that's like analogous to brick in this experiment. So that's our closest thing. If this were to be done in a classroom, what we would do is we'd probably have a bunch of different shake tables, and students would come up, or we have a day where we would just build things, because like this house took me like an hour or two, and then we'd experiment with heights, we'd experiment with, I also thought about getting some sand, so that way you have the difference between a solid foundation and like one that isn't a solid, which is a very important difference. And we would just do these experiments for like a day after having this build, and maybe we'd have time, or we'd have another day where we'd strengthen our models to try to figure out our best materials for housing. All right, thank you very much.